Good day. This is the Professor, CBMD PhD, and today's Tuesday, May 16, 2023. It is 8:00 and 14 seconds, p.m. Eastern Daylight Time, and today's research, universe's expansion. So let's hop to it here. Measurement of the universe's expansion rate weighs in our long-standing debate in physics and astronomy. Date May 11, 2023. Source: University of Minnesota. A team used a first-of-its-kind technique to measure the expansion rate of the universe, providing insight that could help more accurately determine the universe's age and help physicists and astronomers better understand the cosmos. In astronomy, there are two precise measurements of the expansion of the universe, also called the Hubble constant. One is calculated from nearby observations of supernova, and the second uses the cosmic microwave background, or radiation, that began to stream freely through the universe shortly after the Big Bang. However, these two measurements differ by about 10%, which has caused widespread debate among physicists and astronomers. If both measurements are accurate, that means scientists' current theory about the makeup of the universe is incomplete. If new independent measurements confirm this disagreement between the two measurements of the Hubble constant, it would become a chink in the armor of our understanding of the cosmos. The big question is, if there is a possible issue with one or both of the measurements, our research addresses that by using an independent, completely different way to measure the expansion rate of the universe. Researchers were able to calculate this value using data from a supernova discovered by Kelly in 2014, the first ever example of a multiple image supernova, meaning that the telescope captured 4 different images of the same cosmic event. After the discovery, teams around the world predicted that the supernova would reappear at a new position in 2015, and the University of Minnesota team detected this additional image. These multiple images appeared because the supernova was gravitationally lensed by a galaxy cluster, a phenomenon in which mass from the cluster bends and magnifies light. And by using the time delays between the appearances of the 2014 and 2015 images, the researchers were able to measure the Hubble constant using a theory developed in 1964 that had previously been impossible to put into practice. The researchers' findings don't absolutely settle the debate, but they do provide more insight into the problem and bring physicists closer to obtaining the most accurate measurement of the universe's age. The scientific measurement favors the value from the cosmic microwave background, although it is not in strong disagreement with the supernova value. If observations of future supernova that are also gravitationally lensed by clusters yield a similar result, then it would identify an issue with the current supernova value, or with our understanding of galaxy cluster dark matter. Using the same data, the researchers found that some current models of galaxy cluster dark matter were able to explain their observations of the supernova, and this allowed them to determine the most accurate models for the locations of dark matter in the galaxy cluster, a question that has long plagued astronomers. And this is a Professor of Astrophysics, Advanced Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.